Good day, everyone. Welcome to my channel once again. Please, if you know you haven't subscribed to this channel, support the channel by simply clicking on the subscribe button. Today, we'll be looking at a very interesting concept in chemistry called reduction oxidation reactions, which is shortened as what? Redox reaction. So, for those of us preparing for external exams such as WAEC, NECO, JAMB, post-UTME in Nigeria, this is a topic in chemistry that you can't avoid. So please get your notebooks, get your pen. Let's delve into the topic. Now let's quickly define the meaning of those terms. Have you ever wondered why iron rusts? Have you ever thought about it? Why you have a new nail today, after a while, all of a sudden it rusts and turns to brown. What is the reaction occurring there? From this topic, you are going to learn that is actually a what? A redox reaction. But before we go deeper, let's learn the meaning of the terms reduction and oxidation. The terms reduction and oxidation has been defined in various ways over the years. So we're going to look at each of the definitions, and then we'll discuss the present definition that would be most helpful to us in this topic. So firstly, we're going to define oxidation and reduction in terms of oxygen. Okay? So in terms of oxygen, there's the first definition. Oxidation is defined as the addition of oxygen to a substance. So we have addition of oxygen is what we call oxidation. And then the removal of oxygen is what we call reduction. It's as simple as that. Whenever oxygen is being added to a substance, we say that process is called oxidation. Whenever oxygen is being removed from a substance, that process we call what? Reduction. Now, having said this, we can therefore infer that respiration, as we all know, is a redox reaction. Because in respiration, what happens is what? We take in what? Atmospheric oxygen through our lungs, which reacts with glucose, the food in our stomach, and the food gets broken down to what? Carbon 4 oxide and then water. That is a redox reaction. Why? Oxygen is being added to a substance. That is an oxidation reaction. Now, you should note that reduction and oxidation are not two separate reactions. They are two reactions that occur at the same time. We call them complementary reaction, meaning that whenever oxidation occurs, reduction also occurs simultaneously alongside. So they are not two separate reactions, as they cannot independently stand on their own. Hence, we call them complementary reactions. For us to understand the definitions in terms of oxygen, I'm going to give an example on the board. Let's say we have carbon, which is a solid, reacting with zinc oxide, and then our product is carbon 4 oxide, and then we have zinc, solid. Carbon 4 oxide is a gas. This is a solid. So let's look at this reaction together. Is this reaction balanced? Of course, no. We have two oxygen atoms here. So I would need to put a 2 here. So we have two zinc atoms, so we'll place a 2 here. Now, is this a redox reaction? Let's find out. Now, if you look at carbon, you focus on each of the substances, one after the other. If you look at carbon on the reactant side, and this is carbon on the product side, if I should draw an arrow Let's say this is the arrow from the reactant side down to the product side. What do you notice on the reactant side? Carbon is alone on its own. But what do you notice here? Oxygen is now with carbon. So we can now say that what? Oxygen has been added to carbon. And we know addition of oxygen is known as what? Oxidation. So this process now, we call it oxidation. The transition from carbon to carbon dioxide is an oxidation process. Now, if you look at this is zinc together with oxygen over here. Now look at the transition. This is zinc on the product side. Now, if you look at this reactant side, zinc is being bonded to oxygen. But in the product side, oxygen has been removed. So the removal of oxygen from the zinc oxide now, remember, removal of oxygen is known as reduction. So this is reduction. So in terms of oxygen, I've shown you how to know the substance that is oxidized and the substance that is reduced. In chemistry, we say carbon is being oxidized in this reaction, while zinc oxide is being reduced. That said, the next thing you should be able to identify is what we call our oxidizing agent and our reducing agent. Yes. Now, what is an oxidizing agent? Oxidizing agent is that species in the reaction that makes oxidation possible. What do we mean? If you look at this is our oxidation arrow. So looking at this critically, carbon was oxidized. Why was carbon oxidized? Because oxygen was added. But the question is, which species in this reaction gave this oxygen we're talking about to carbon? You agree with me that the oxygen that carbon is combining with, it's coming from what? Zinc oxide. So the substance that donates the oxygen to the carbon, we call that substance your oxidizing agent. So this is your oxidizing agent. Now that said, now let's come to this. Zinc oxide is being reduced. Why is it being reduced? Because zinc oxide is losing oxygen. But then remember, zinc oxide wouldn't have been able to lose that oxygen if there was no carbon to accept that oxygen. So we can now therefore say that what now? The substance that is responsible for the reduction of zinc oxide is actually what now? Carbon. So we call carbon the what? Reducing agent. Because it was carbon that caused the reduction, which is the removal of the oxygen from the what? Zinc oxide. Now we're going to make a general rule for ourselves here that will help us in this topic. The substance that is oxidized, which is carbon now, is usually the reducing agent. Not usually even, it's always the reducing agent. While the substance that is reduced, zinc oxide is being reduced, the substance being reduced is the oxidizing agent. I would advise you to write that point down. I repeat, the substance that is oxidized is your reducing agent, while the substance that is reduced is your oxidizing agent. So we can now define oxidizing agent in terms of oxygen as what? A substance that does what? That donates oxygen. While we define reducing agent in terms of oxygen as a substance that does what? That accepts oxygen. That is all for the definitions in terms of what? Oxygen. Now the next definition we're going to be looking at now is in terms of hydrogen. Yes. So we have dealt with this in terms of hydrogen. Now, in terms of hydrogen, the addition of hydrogen to a substance is what we call reduction. While the removal of hydrogen from a substance is what we call oxidation. Now, if you look at it critically, the definition for hydrogen is directly opposite to that of what? Oxygen. So in terms of hydrogen, oxidation is the addition of hydrogen to a substance. Whenever hydrogen is added to a substance, we call that a reduction process. While whenever hydrogen is removed from a substance, we call that an oxidation process. Now, for this to be crystal clear, I'm going to write an equation on the board. We're going to determine which substance is oxidized, which substance is reduced, as well as determining the oxidizing agent and the reducing agent. So let's take this example from my notes over here. We have hydrogen sulfide, for instance, reacting with chlorine gas to produce hydrogen chloride, and then deposits of sulfur, which is a solid. All right. Then to balance this equation, of course, we have a 2 here. And I think our equation is balanced. Now, let's pay attention to this now. If I ask you, if JAMB should ask you, if your exam should ask you, which substance is being oxidized here in terms of hydrogen now, what do you do? Very simple. First of all, draw the arrows to guide yourself. Now, this is sulfur, okay, in the reactant side, and then this is sulfur in the product side. So I would draw an arrow from this to this. Then this is chlorine here, and then this is chlorine in the product side. You connect them with an arrow. All right, let's look at each of the transition. From hydrogen sulfide, we transited to neutral sulfur. What do we notice? It means that hydrogen was removed from this hydrogen sulfide to have just ordinary sulfur here. So it therefore means the removal of what now? Hydrogen from the hydrogen sulfide, removal of hydrogen is equivalent to what? Oxidation. So this arrow represents my arrow for what? Oxidation. So remember, the substance that is oxidized is your reducing agent. We will be working with that rule henceforth. Now let's look at chlorine. Chlorine is just on its own. No different element is with chlorine here. But look at chlorine in the product side. Chlorine is now bonded to hydrogen. So what can we say? It means hydrogen was added to this chlorine gas. And addition of hydrogen is known as what? Reduction. So it means chlorine was reduced. Now remember that the substance that is reduced now becomes your oxidizing agent. So that is how you know which substance is oxidized, which substance is what? Is reduced. And then your reducing agent and your oxidizing agent. Now the third definition is in terms of electropositive and electronegative element. I won't dwell so much on that because looking at it, those definitions are just the same with the definitions of oxygen and hydrogen. Having in mind that what? Oxygen is an electronegative element. What do I mean? For oxygen to achieve the octet configuration of the noble gases, oxygen would need to accept electron. And when an element accepts electron, it becomes what? Negatively charged. So oxygen is electronegative. This electronegative. While hydrogen is electropositive in acids, right? Electropositive. So we can now define what now? Oxidation in terms of electronegative elements is what? The addition of an electronegative element to a substance. While reduction is the removal of an electronegative element from a substance. If I say define oxidation and reduction in terms of electropositive element, you are following the definition of hydrogen. You say what? Reduction is the addition of an electropositive element, while oxidation is the what? The removal of an electropositive element. So these are the preliminary definitions. But the definitions we are going to be making use of mostly in our exam is in terms of electron transfer. So quickly, I'm going to take off what I have on the board and then actually explain in terms of electron transfer very well. All right. Now, let's look at in terms of what? Electron transfer. Now, from what we've learned about electrovalent combination, which is a type of chemical combination that involves the transfer and reception of what? Electrons. We've learned that whenever electrons are being transferred or received, an atom gains a charge. Normally, atoms are electrically neutral because they contain equal number of protons and what? Electrons. Okay? But whenever an atom loses electron or gains electron, that balance is being altered. For metallic atoms, which are atoms that usually donate electrons to other atoms, what happens? They tend to acquire what now? A positive charge. For example, sodium. When sodium loses one electron, it becomes a sodium ion. But then in chemistry, we don't write the negative sign. So I'm going to take this electron over to the other part of the board. So this would leave, and then I write it here. The negative changes to positive. So this process now, we call this process oxidation. So hence, in terms of electron transfer, we have that what? Oxidation is defined as any process that involves a loss of electron. So a substance is oxidized if it loses electron. And you would understand now that what? The oxidation number of sodium atom in the neutral state is 0. But now, in the product side, we now have a charge of +1. So from 0 to +1, that is an increment. So how do I actually recognize the substance that is being oxidized from this now? It means that any substance that contains an element whose oxidation number increase, such substance in the reaction is said to have been what? Oxidized. So in this case, sodium is oxidized. Why? Because the oxidation number increased from 0 to +1. Now, the electron being lost, sodium cannot just lose electron. There must be somebody available to collect that electron. So a common example we use is chlorine now. For chlorine to become stable, by stable we mean achieve the octet configuration of the noble gas, what must chlorine do? Chlorine have to accept one electron, like we all know. So when this happens, we now write chlorine as Cl-. This process is what we call a reduction process. Now, what do you notice? Before chlorine accepts this electron, the oxidation state is 0. Take note, the oxidation state of an element in the free state, meaning when that element is not bonded to a different element, the oxidation state of that element is always 0. That is a rule you should always know. So when chlorine accepts this electron, it now acquires a -1 charge. So we can now see that what the oxidation number of chlorine does what now? Reduces from 0 to -1. Hence, this process now is called a what now? A reduction. So it's a reduction because the oxidation number of chlorine reduces to -1. So for you to remember the definition of oxidation and reduction in terms of electron transfer, there is a common acronym we use. We write oil rig. Oil rig. So this is to remind you that oxidation is loss, while reduction is gain. So sodium loses the electron, we say sodium is oxidized. Chlorine accepted electron, we say chlorine is being reduced. Now, remember the substance that is oxidized, which is sodium now, is your what? Reducing agent. That's the rule we're working with. While the substance that is reduced, in this case, which is chlorine, is your what now? Oxidizing agent. So if we are to write an overall equation for this process, we can say what now? Sodium combines with chlorine. Remember, chlorine gas is diatomic to give us aggregate of sodium chloride. So this equation is not balanced. To make chlorine balanced, I'll place a 2 here. And then this is 2 sodium, so I place a 2 over here. So this becomes your balanced equation. Now, in this process now, what is being oxidized now is what? From sodium to this is your oxidation, this oxidation. While chlorine changing to this is what now? Is your reduction. The substance that is oxidized, remember, this is your reducing agent, while the substance that is reduced is your oxidizing agent. So one key thing that is going to help you to answer your questions correctly in your exam is for you to know how to calculate the oxidation number of each element, especially the central element. Not really hydrogen, not really oxygen, but you must know how to calculate the oxidation number of the other elements in the reaction. Generally, group 1 elements usually have an oxidation state of +1 in their ionic form, while group 2 elements, their ions usually have a charge of what now? +2. Take note of that. The oxidation state of hydrogen most times is +1, except in hydrides or when hydrogen is being bonded to elements that have more metallic character than itself. Hydrogen would have a charge of -1 in those cases. Oxygen, the oxidation state of oxygen most times is what? -2 in most compounds, except in peroxides. In the case of peroxides, the oxidation state of oxygen becomes -1. These are basic rules you should have at the back of your mind for you to be able to answer your questions correctly. So before we go into answering past questions, I would need to teach you with examples on how to calculate the oxidation number of a particular element in a compound or a radical. So we'll dive into that while I take this off the board now. Okay, now let's look at how to calculate the oxidation number of an element in a compound or a radical. So firstly, what's the difference between a compound and a radical? The difference is this. If I should write sodium chloride, NaCl, is this a compound or a radical? If I should write SO4 2 minus, is this a compound or a radical? Now, let's learn the difference between them. For a compound, the sum of the oxidation numbers of the elements that constitute a compound must always give you 0. It means whenever you have group of atoms together and then the total charge is 0, as you can see, there's nothing here. The total charge is 0. Just know that such a substance is called a compound. So the oxidation state of a compound is 0. Why is it 0? Because if you add up the component oxidation states together to give you 0, what do we mean? Sodium, we already know in this place, has a charge of +1. Chlorine over here has a charge of -1. So by the time you combine both together in mathematics, you should know that +1 minus 1 is equal to 0. So the sum total of the oxidation number of the elements that make up any compound is always equal to 0. We're going to use this rule in calculating briefly. Now, if you are given a substance that carries a charge, in this case, it means that what? The summation of the oxidation numbers here will be equal to this. So group of elements together acting as one unit and carrying a charge, we call this a radical. A radical. Okay. So the oxidation number of this radical now, this number here, this -2, is gotten by adding up the oxidation states of sulfur and oxygen over here. So looking at it now, this is pronounced as tetraoxosulfate 6. Whenever somebody says tetraoxosulfate 6, that 6 being mentioned actually refers to the oxidation state of the element mentioned before the 6. So when it says sulfate 6, it means sulfur here has an oxidation state of 6. So when you add that to the oxidation state of oxygen, I've told you is always -2 except in peroxides. So we have -2 here and we have 4 oxygen here. So that's 4 times -2. So if we should solve that, that would be equal to 6 minus 8. 4 times 2 plus 4 times -2 is -8. And 6 minus 8 gives you -2. So that is how this -2 is gotten. So for you to get the charge of your what? Your radical, what do? You add up the oxidation state of all the elements. That said, now let's look at some common examples now. Now, if I should tell you, for instance, what is the oxidation state of chlorine in NaClO3? We're trying to get the oxidation state of chlorine. First thing you should ask yourself is this a compound or is this a radical? Of course, we should know it's a compound. Why is it a compound? Because there is no charge written on top, though, so the charge here is 0. So how do we now get the oxidation state of the chlorine? Remember what we said? The addition of all the oxidation state of the element that make up a compound should give you 0. So we simply come down and say, this implies that what? The oxidation state of sodium is +1. Sodium is a group 1 element, I've told you. So the atomic number of sodium is 11. The electronic configuration of sodium is going to be what? 281. This sodium. So if sodium wants to become okay, sodium have to lose 1 electron. Any element that loses electron is positively charged. The ion will be positive. Then how many electrons did it lose? 1. So we say sodium has a charge of +1 added to. We are trying to get the oxidation state of chlorine. So we don't know that. I will leave that. Then added to, we have 3 oxygens here. So you multiply it 3 times. The oxidation state of oxygen is -2. So the rule says the answer must give you what? 0. So you solve this. This will be what? 1 plus chlorine minus 6 is equal to 0. So chlorine will be equal to, when you take 1 to the other side, it becomes -1. Take -6, it becomes +6. So chlorine will be equal to what? +5. So the oxidation state of chlorine is +5 in this compound. Let's do an example on a radical. If I should ask you to calculate the oxidation states of phosphorus in PO4 3-, what is the oxidation state of phosphorus in PO4 3-? So we're looking for phosphorus, so you leave it as P. I'm adding up all the oxidation states now. Added to, we have 4 oxygens here. You write your 4, then you multiply it with, I told you oxygen is -2 in most compounds. Then in this case, since it's a radical, it must be equal to the charge of the radical. So for you to get the charge now, you place a -3 here. So when you add up the total oxidation state in the radical, always write equal to this number you see on top here. For a compound, we wrote equal to 0 because we have 0 here. So if you solve this, this will be P -8 equal to -3. Collect like terms, take -8 over, you have P is equal to -3 plus 8, which gives me +5. So the oxidation state of phosphorus in this compound is +5. So this is how you know the oxidation state of a particular element in either a compound or a radical. Now, what do we use these basic rules for? You can use this rule in your exam to get the formula of a compound or a radical, or to name a radical or a compound if given the formula. So I'm going to be writing 2 JAMB questions on the board, and we're going to solve them together now. Okay, now let's look at this question on the board. The chemical formula for potassium hexacyanoferrate 3 is dash. And then you have your options. This is JAMB 2023, number 8 question. Now, how do you tackle this if you see this in your exam, using your knowledge of oxidation number? Firstly, deal with this other part. Deal with the radical part, which is hexacyanoferrate 3. So I'll pick just that part first and deal with that. So firstly, I will deal with hexacyanoferrate 3. So if I'm picking just that part, it becomes an ion. It's going to have a charge. Okay? So what do we do here? When you hear the word hexa, hex generally means 6. Now, cyano, the cyano group, the formula in chemistry is Cn. Okay, that's your cyano group. Cn. When you hear the word ferrite, ferrite is iron. The Greek, is it the Greek? But it's one of the names for what? For iron. Ferrum, actually, the Greek name of iron. But we call it ferrite in this case. So whenever you hear ferrite, it refers to iron. So bringing all this together, it means we have 6 cyano group, then we have iron together with it. So if we are to write that, we say Fe, then bracket Cn, then 6. So this would be a radical. So for it to be a radical, it means it would have a charge here. I believe this is clear. Why am I writing 6? Because of the word hex. Hex means 6. Hexa, cyano, meaning 6 cyano group. This is the formula for the cyano group. Then ferrite, you are moving from this part this way. So iron, you write the symbol. Then why am I putting X on top? Because this is an ion. Why is it an ion? Because I excluded the potassium from the name. It becomes an ion. So the question is, how do we get the charge of this radical? I just told you in some few minutes back that for you to know the charge of a radical, you are adding up the oxidation state of everything here. So if we do that, the oxidation state of iron is already in the name here. They said ferrite 3. I just told you that those numbers being mentioned in the IUPAC name of inorganic compound represent the oxidation numbers of the elements mentioned before them. So this 3 belongs to iron. So working with the rule I just said, to get the charge of this radical, X will simply be the oxidation state of iron, which is 3, added to, we have 6 cyano group. 6 into the oxidation state of the cyano group is -1, Cn minus, take note. So this is -1. By the way, this is what we call a complex ion. Okay, so if we are to solve this, we are going to have X would be equal to 3 minus 6. X becomes -3. So we've gotten our charge over here. Now, after getting your charge, you can now combine. So we can now say our results here is what? Fe, Cn, then 6. Then the charge is 3 minus. So this gives us the what now? The ionic symbol for hexacyanoferrate 3. Now we can now combine potassium with it now. So my next stage, I write potassium hexacyanoferrate 3. So when you are adding the potassium, it's no longer an ion, it's now a compound. So what do? You write a symbol for potassium. Potassium is K. Then hexacyanoferrate 3 is what I have gotten here. So I'll write it here. That's Fe, open bracket, Cn, 6. Then we have 3 minus over here. Now, the valency, the next thing you must do when you are getting formulas, you must ensure that you write the valencies of the component or the oxidation number. The oxidation number of potassium is 1 plus. I'm just placing the 1. In chemistry, we don't write 1. But whenever you want to get formulas, what you make use of is the valency. Meaning, with valency means we don't really care about the positive or the negative sign. So that those would leave. And then you exchange the valencies as subscripts. So this 3 goes to potassium, this 1 goes over here. So your answer simply becomes K3. Then whenever a number is going to meet a group of elements like this, you enclose in a bracket. So you have Fe, Cn, then 6. Then you have 1 outside. But then, as we all know, 1 is pretty much useless. So if you should throw away this 1 out, the bracket also becomes pretty useless. So your final answer becomes K3 Fe bracket Cn, then 6. So this becomes your formula. And that corresponds to option what? Option B. So that is how you get the formula of a compound using the knowledge of oxidation number that we just talked about. I believe this is super clear. We'll take one more question before we continue. All right. Now, let's look at this second example. The IUPAC nomenclature of the compound LiAlH4 is dash, and then you have your options. This JAMB 2010, number 23. So in the previous example we just did, we were given the name, asked to look for the formula. Now we're being given the formula, we're told to write the IUPAC name. So what do you do in this case? You write LiAlH4. So will be equal to what now? You try naming it. You always start your naming. This is actually composed of lithium, and then this is a radical. AlH4 is a radical on its own. So the first thing you name is always the metal, the metallic part. Lithium is the best metal. Lithium is a metal, aluminum is also a metal. But lithium is a stronger metal than what? Aluminum. So I'm going to start my naming from what? From lithium now, which is the most electropositive element here. So you name as lithium, then in naming AlH4, you come to the part of hydrogen first. So we have 4 hydrogen. 4 is named as tetra. Then hydrogen in this case is actually behaving like a hydride. What do I mean? Remember I told you when hydrogen is bonded to other metals that are more metallic than itself, it behaves as a non-metal in that case. So this is called, hydrogen here is having the hydride ion, which is the oxidation state of hydrogen here is not +1, it's actually what? -1. It is acting as a non-metal in this case because it is being bonded to 2 other elements that are more metallic in character than itself. So we now pronounce hydrogen not as hydrogen, rather we pronounce it as what? Hydrido or hydrido. So this is lithium tetrahydrido. Then this is aluminum, but you don't pronounce it as aluminium. You now pronounce it as what? Aluminate. So we say aluminate. Aluminate. Then you include the oxidation state of what now? Aluminium. So how do I get the oxidation state of aluminium? I could just take it to be X, for instance. So how do we calculate for it? So to calculate for it, remember this is a compound. The total charge there is 0. So if you add up all the charges here, the answer should be 0. So the oxidation state of lithium, lithium is a group 1 element. So the oxidation state of lithium is +1. Added to the oxidation state of aluminium is what I've taken here to be X. Aluminate X. Added to, this is 4 hydrogen, you write your 4 times. The oxidation state of hydrogen here is not +1, rather is -1. I've explained why. And the result gives you 0. So this will be 1 plus X minus 4 equal to 0. So X will be equal to 1 crosses to become -1, -4 crosses to become +4. So X become plus what? +3. So we can now say the name of the compound is what? Lithium tetrahydroaluminate. This is your X now. I've calculated it to be 3. Then you look for your correct option. I think that is option C. So that is how you solve a problem like this. Now, I'll take up what I have on the board, but then we are going over to the tests for oxidizing agent and what? Reducing agent. It's another aspect that will be tested for in your exam. So I'll take up this now. Okay, now let's look at the test for oxidizing agent, meaning how do I know if a particular reagent, if a particular chemical is an oxidizing agent? To test for oxidizing agent, okay, you react that oxidizing agent with a reducing agent and then take note of the observable changes, mostly in terms of color. That's what we do in chemistry. So the reducing agents we use to test for oxidizing agents, there are actually 2. Okay, so these are the reducing agents you can make use of to test for oxidizing agents. You can make use of iron 2 chloride, which is FeCl2. or you can make use of hydrogen sulfide. So why is iron 2 chloride even a reducing agent? Remember from what we have learned so far, reducing agents are substances whose oxidation number can do what? Increase. That's just simply what it means. Because reducing agents are substances that do what? Gain electrons rather. Not gain, rather. Reducing agents are substances that actually do what? Lose electrons. They release electron. In the process of releasing electron, their oxidation number will do what? Increase. So looking at this now, the oxidation number of iron in this particular compound is +2. If you should split this up, that's the same thing as saying Fe2 plus, then we have 2 chloride ions there. So the oxidation number of iron here is +2. If you should calculate it with the rules we just learned. If you take iron now to be X, the oxidation state of iron to be X, you are going to have that X added to chlorine. We have 2 chlorine times, the oxidation state of chlorine is -1. So for a compound, we said the total charge to be 0. So X will be equal to, so let's say X minus 2 will be equal to 0. So S will be equal to +2. So this is what I have. So with experience, you wouldn't even need to be solving this, but for the sake of simplicity, we're going to be solving it like this, so everybody is carried along. So the oxidation state of iron here is +2, but we all know that iron exhibits 2 oxidation states. Just in case you don't know, we have iron 2 and we also have iron 3. So there's the possibility of ion's oxidation state increasing from +2 to +3 when it loses another electron. Hence, iron 2 chloride is a reducing agent. So you could just write this down in your note that what? Reducing agents are substances that contain an element whose oxidation number can increase from what it is presently. So iron 2 chloride is a reducing agent. What about hydrogen sulfide? It's also a reducing agent. Why? Remember, when I am dealing with this, I'm focusing on the central element. The central element is not hydrogen now. The central element is actually what now? Sulfur. The oxidation state of sulfur here is -2. If you should calculate it. So hydrogen here is positive. So if you have 2 times 1 plus the oxidation state of sulfur, we don't know, should be equal to 0 like we have said. So this will give you 2 times 1 is 2 plus S equal to 0. So S become -2. So the oxidation state of sulfur here is -2. Sulfur's oxidation state can definitely increase from this -2 to 0, which is neutral sulfur. It can also increase even from 0 to 4, which is also an oxidation state of sulfur, even to 6. So hydrogen sulfide is a reducing agent. Why? Because the oxidation state of sulfur can increase from -2 to 0 to 4 or to even 6. Now, what happens when you react an oxidizing agent with iron 2 chloride? So if you should react an oxidizing agent with iron 2 chloride, take note that iron is a transition, iron 2 is a transition ion. What do I mean? Transition metals have the ability to form colored ions, remember. So it therefore means that what? Iron 2 has a color as an ion. What is that color? The color is green. So the color of this solution is going to be green. What's causing the green coloration is this iron 2 ion that is here. Iron 2 ion is green. Take note of that. So when you react an oxidizing agent with this, what happens essentially is the iron 2 ion here now, the iron 2 ion, by the time it loses one more electron, will change to become iron 3 ion. Remember, if an element is losing electron, the oxidation number will actually be increasing. So this iron 3, so this is green, and then the color of iron 3 ion is actually brown. Okay? It can be yellow in some condition, but in the hydrated form, it's actually brown. So if you react an oxidizing agent with what? Iron 2 chloride, how do you know that is an oxidizing agent? The color of the iron 2 chloride would change from green, the solution would change from green to brown. Then you know that that substance is an oxidizing agent. What if I react the oxidizing agent with hydrogen sulfide? Okay, hydrogen sulfide is a clear gas, it's a colorless gas. So if you react an oxidizing agent with hydrogen sulfide, what essentially happens is the sulfide ion, which is S2 minus, remember we have said the sulfur here has an oxidation state of -2. The S2 minus will actually do what? Accept electron. I will follow, not accept electron, rather give out electron. When this gives off electron, what happens is what? It becomes what? So it's going to lose, let me write this. This is going to lose 2 electrons. This loses just 1 electron to be this. So the sulfide ion loses 2 electrons to become neutral sulfur. So hydrogen sulfide is colorless. But sulfur, rhombic sulfur, is actually yellow in color. So whenever you pass hydrogen sulfide over an oxidizing agent, what you'll notice is what? You have yellow deposits of sulfur in your test tube. So these are the 2 tests for what? Oxidizing agent. Now, we'll end this video by looking at what? The test for what? Reducing agent. All right, now let's look at the test for reducing agent. So if you want to test if a particular reagent is a reducing agent, there are 2 reagents we make use of in the lab. The first is potassium heptazol dichromate 6, which is K2CR2O7. So this compound in the laboratory has an orange color. Take note. And why is it having an orange color? Essentially because the name of this compound is potassium heptazol dichromate 6. So if you calculate the oxidation state of chromium here, it's going to be 6. All right. So that chromate 6 ion, which is Cr6 plus, this ion is orange in color. So when you react a reducing agent with an oxidizing agent, the oxidizing agent we are going to be looking at here now, there are 2 also. One is K2CR2O7. Then the other is KMNO4. So I've just told you that the color of this compound is orange, while the color of this compound is purple in the laboratory. So the ion that's actually bringing out this orange color, take note, is Cr6 plus. Then this is potassium tetrazole manganate 7. So the ion, the transition ion that produces this purple color is Mn7 plus. So when you react a reducing agent with any of this, what happens? If you are using this reagent, the change that occurs is what? The chromate 6 ion would be reduced. Remember, you are reacting with the reducing agent. Reducing agent causes the oxidation number of something to reduce. So the oxidation state of chromium reduces to Cr3 plus. So what you observe is what? A change in the solution, which is orange, to what now? To green. The color of chromate 3 ion is green. So this is the color change. Take note of this. It's a common question. If you are making use of this other reagent here, which is potassium permanganate solution, the acidified form, take note. You are making use of this, you must add little drops of what? Dilute acid. It helps in the balancing of the equation and the transfer of the electrons. We are going to learn about balancing of equations in our subsequent videos. So, if you are making use of this other reagent, the change there is the manganate 7 ion will be reduced to manganate 2 ion. So manganate 7 ion, like we've said, the color is purple. Then manganate 2 plus ion is non-transitional, meaning it's colorless. It's a colorless ion. So whenever you react a reducing agent with potassium dichromate solution, you have a change of color from orange to green. If you react with what? Manganate 7 solution, potassium permanganate solution, you experience a color change from purple to a clear colorless solution. So these are the tests for what? Reducing agents. Now, for this video not to be long, we're going to cut it here. But before then, I'm going to write out some questions on tests for reducing agent. Now, you should take note that it is possible for a particular substance to behave as both an oxidizing agent and a reducing agent. Yes. For example, sulfur 4 oxide is a common example of such a substance. It can behave as an oxidizing agent. Why? Because remember, oxidizing agents are substances that do what? Accept electrons. So when they accept electrons, their oxidation state decrease. So in sulfur 4 oxide, the oxidation state of sulfur is 4. So there's the ability of the oxidation state reducing from 4 to what? To 0 or even -2. Also, it can also act as a reducing agent. Remember that the oxidation state of reducing agents should increase. So the oxidation state of sulfur in sulfur 4 oxide is 4. We also have a possible oxidation state of sulfur is also 6, like tetrahydrosulfate, 6 ion. So the oxidation state of sulfur can also increase from 4 to +6. So you can see, because of that, sulfur 4 oxide can behave as both an oxidizing agent and what? A reducing agent, just in case you are asked such a question. So we're going to draw the curtain close today. I'm going to place some questions on the board. Please comment your answers. Drop your answers in the comment section below. Thank you. All right. So you have your evaluation questions here. You can pause the video and then answer them. Drop your answers in the comment section. Please don't forget, if you found this video helpful, support the channel by liking this video and subscribing. Also share with your friends. Now, the part 2 of this video will be dropping soon, and there we're going to be solving JAMB problems on how to identify oxidizing agents, reducing agents, which substance is oxidized and which substance is reduced. Watch out for the next video. Thank you for sticking around.